This is a hypothesis testing problem requiring the use of an average and also a small sample. We have a hypothesized mean of 7, and we're supposed to test whether or not the data is consistent with that mean, and the problem specifically says to use a two-sided alternative. So the null hypothesis will be that the mean is equal to 7, while the alternative hypothesis is that the mean is not equal to 7. Okay, we have a small sample, which means I need to figure out the test statistic t. That'll be the observed average minus the mean divided by the sample standard deviation over the square root of n. In our problem, that is 6.68 minus the hypothesized mean of 7 divided by 0.2 over the square root of 6. Okay, so that'll be equal to 6.68 minus 7 over 0.2 over the square root of 6. So I get a t-value of negative 3.919. Okay, now at this point we have two choices. We can either figure out the p-value or the critical value. I'll do it both ways. To figure out the p-value, either using a calculator or else Microsoft Excel. Negative 3.919 is over here. And so I need to find the area to the left and also the corresponding area to the right. So that means figuring out the p-value. Okay, so let me copy this over to the side just so I can mark it. So there's the t-value. The p-value, well, there's a few ways of getting this. The first way of doing this would be doing t.dist of this number with 5 degrees of freedom, n minus 1. It's cumulative, so true, and then multiplying that by 2. Okay, so taking the area to the left of negative 3.919, taking this area to the left and then just simply doubling it because the t-value, the t-distribution is symmetric about 0. This is kind of what you would do on a TI calculator, is to find the area to the left and then double it. So if we hit enter, we get 0.01 as the p-value. So 0.0112. Let me talk about a couple alternative ways of doing this. Another way of doing this would be t.dist .rt with negative that number with 5 degrees of freedom times 2. So that would be the right-tailed area to the right of positive 3.919. And then I would get the same answer. A second way of doing it, now what I'm about to type is incorrect, I believe, t.dist.2t of this number, 5. And I believe this is going to return an error. And the reason it returns an error is because the function t.dist.2t insists on having a negative number in a positive number in the first argument. So I need to have positive 3.91, not negative 3.919 in the first argument. So this would return also 0.0112. Finally, I'm going to talk about what to do if you have a Excel 2007 t-dist. We would input the x-coordinate, which again has to be positive, 5 degrees of freedom, and this time I put in 2 for 2 tails. We have the third argument would be the number of tails that you have. In this case, it's 2 tails, and again we get 0.0112. So that would be the commands in Excel, depending on if you have Excel 2010 or Excel 2007. If you have a TI calculator doing this calculation, most likely you would do something equivalent to 2 times the area to the left. Something like that, except you'd be using the tcdf command on the TI calculator in order to figure out the area to the left. So, and forgot it's on the t-dist. We need to have the true to say that it's cumulative to get the p-value. So that's the p-value. Now, if the other way of doing this problem would be to figure out the critical value. So let's do that in red here at the top of the screen. To figure out the critical value, well, unless it says otherwise, we have alpha to be equal to 0.05, so we'll take that to be our assumption for this problem. So that means I need to figure out the values of t so that the combined area that is shaded here is 5%, meaning that there's 2.5% on the left tail and 2.5% in the right tail. This cannot be easily found on the TI-83 calculator. I believe there's a command that will do this on the TI-84, but it's not particularly easy to do on the TI-83. You can use the table that will be provided on the exam. Another way to do this would be the t.inv.2t command, 0.05 with 5 degrees of freedom. So this would probably be my recommended way of doing that to figure out the critical value, so that the combined area in both tails is 5% with 5 degrees of freedom for a cutoff of 2.57. So I'll mark that here, 2.5706. And of course the other extreme would be negative 2.5706. Another way of figuring this out, I don't particularly recommend it, but I put it here for the sake of completion, would be t.inv of 0.025 with 5 degrees of freedom, so that 2.5% of the area would lie to the left, and that should return this mark here, negative 2.57. It does. In Excel 2007, the command is tinv. You don't have the t.inv command in Excel 2007. And this time you automatically, and let me put the, you notice that in the notes here it says that this is automatically returns a two-tailed inverse. So the first argument will be 0.05 and 5 degrees of freedom, and I get again 2.5706. Okay, so there's the critical values. In our case, the t-statistic of negative 3.9 falls over here in the rejection region, and so our decision will be to reject the null hypothesis. Okay, so in words, I'll just type it out for the sake of speed. We reject the null hypothesis. It appears that the mean pH is different than 7. So that would be our conclusion stated in plain English.